Niyati Chauhan, Assistant Professor at LC Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Safety Instrumented System, Unit 4, Protection Layers. So let's start today's session. First we discuss risk reduction and safety integrity. We know that there is a common saying in the control system world. If you want to control something, first make sure you can measure it. We need to control the risk of harm or losses in the workplace due to hazard of all forms. So that we need to measure is risk. Here we need to clear on term hazard and risk. So first we clear two words. What is hazard and what is risk? So first, what is hazard? A hazard is an inherent physical or chemical characteristic that has the potential for causing harm to people, property, or the environment. In chemical processes, it is the combination of a hazard material and operating environment and certain unplanned events that could result in an accident. Okay. So here we have discussed what is hazard, right? The hazard most commonly found in process industries are those due to first, explosions or wasting due to large amount of stored energy, chemical reactions, or release of flammable vapors. Fires due to combustion of chemical substance internally or externally to the process or through overheating of equipment. Toxic release and explosions or entrapment in gas-filled spaces. Then, mechanical hazards due to large machines, materials handling, steam and gas discharges. Next is what is risk? Risk is usually defined as combination of the severity and probability of an event. In other words, how often it happens and how bad is it when it does happen. Risk can be evaluated qualitatively or quantitatively. So risk is equal to frequency into consequence of hazard. So risk reduction can be achieved by reducing either the frequency of a hazard event or its consequence or by reducing with them. Generally, the most desirable approach is to first reduce the frequency since all events are likely to have cost implications even without dire consequence. So, safety systems are all about risk reduction. If we can't take away the hazard, we shall have to reduce the risk. To know how to do this, it helps to look at theory measuring risk and then reducing it. So next, measurement of risk. Risk can be evaluated qualitatively or quantitatively. The approach requires that we describe risk in descriptive terms such as high or moderate. These terms are only effective if everyone has a good understanding of what they mean in the context of use. So here you can see graph of to reduce risk. So on x-axis we have a take axis we have taken risk, right? If we reduce frequency, then we can reduce risk. So for minor injury, we can see in graph is linear. Okay. Then after for serious injury and for fatal, you can see frequency and risk both are is not in proportional form. Okay, so you can see in graph. So we know that equation risk is equal to frequency into consequence of hazard. So if we reduce frequency and consequence, then we can reduce risk in our plant. As shown in figure, right? On next slide, you can see figure. I am discussing about this figure. As shown in figure, a plant without a safety system may have an unprotected risk frequency of F and P, right? F and P, that means unprotected risk frequency, which is reduced to a protected risk frequency FP by adding a safety system. The risk reduction provided by the safety instrumented system is called the risk reduction factor RRF and is simply the ratio of unprotected risk to the protected risk frequency is called risk reduction factor. So RRF is equal to FNP upon FP. So here you can see in diagram process equipment to signal sent to the control system, right? So this is called FMP, right? Then after process equipment to signal sent to the safety system, right? And safety system to signal sent to the process equipment is called FP. So F and P upon FP is called risk reduction factor. This sample ratio makes RRF a very effective index of safety system performance or integrity. Introducing safety integrity levels. We have noted that safety integrity depends on hardware and design. We have seen that the required RRF provides a scale of performance for the ability of a safety system to reduce risk. We can use risk reduction factor as a measure of safety integrity. So we have discussed about risk and hazard, then after how to reduce risk in our plant, then different safety integrity levels are available. So first we have to know about what is safety integrity level. So safety integrity level is defined as a relative levels of risk reduction provided by a safety function or to specify a target level of risk reduction. In simple terms, SIL is a measurement of performance required for a safety instrumented system. The requirements for a given SIL are not consistent among all of the functional safety standards, right? Means SIL not depend on all standards, right? Here SIL depend on IEC 61508 standard. In the functional safety standard based on the IEC 61508 standard, for SILs are defined with SIL 4, the most dependable, and SIL 1, the least. The applicable SIL is determined based on number of quantitative factors in combination with qualitative factors such as a development process and safety life cycle management. So here you can see one chart is shown on your screen, and this is related to SIL different levels. So first SIL 1, then SIL 2, SIL 3 and SIL 4. That is safety integrity level. Then second column is for safety, then third column is for probability of failure on demand, and last column, that is risk reduction factor. For SIL1, safety is 90 to 99% and probability failure rate 1% to 10%. And risk reduction factor 100 to 10 means in last column for risk reduction. For SIL2, safety for SIL2, safety 90% to 99.9% and probability failure 0.1% to 1% and risk reduction 1000 to 100. Rate for SIL3 99.9% to 99.99% and probability failure 0.01% to 0.1% and risk reduction factor 10,000 to 1,000. And for level 4, safety greater than 99.9% and probability of failure demand 0.001 to 0.01% and risk reduction factor 1 lakh to 10,000. Okay, so in exam asked about SIL, right? So you have to draw this table in exam. Thank you for watching video. If you have any query in this session, then you can ask me.